Okay, we had these four numbers to classify. Let's think about where each one goes. Okay, let's see. We've got this huge number system, all the real numbers split into two different categories. Let's try to find if any of these are irrational. Remember, if you're irrational, you're a number that you can't write as a fraction. These are the weird numbers like pi and like square roots of non-perfect squares. And basically, irrational numbers are decimals that go on forever without repeating. And so clearly, the only thing that could fall into that category is this one. So even though there's a little pattern to it, it's point 12, 13, 14, and so on, there's nothing that is repeating. We can't put a bar over any of those digits. So that is irrational. Okay, then we get to, let's say, negative 14. Well, negative 14 is clearly in the rational category because we can put a 1 underneath it and it's written as a fraction, right? But let's see if it also classifies as anything else. We know that integers are all the numbers that don't have decimals or fractions. So they're essentially like positive and negative whole numbers. And so that's where negative 14 will reside. It's not whole or natural because it's got that negative sign in front. But understand, of course, that if it is an integer, then it's clearly also in the rational side of the diagram. So it is also rational. So you would want to check off both of those. 2/5 is a fraction, which means it has to be in the rational side. But it's not an integer because it has a fraction. Remember, integers don't have fractions or decimals. So this is really as far as that guy will go. So really 2/5 is just rational, that's it. And then we get 0. Well, we'd like to put 0 in the natural category, but remember, natural numbers are counting numbers. We start at 1, and so it has to go in the whole number box here. And remember, if it is whole, that means it's also an integer, oops, and it's also rational.